Hello all, welcome to the next topic from units and dimensions, which is called vernier caliper. Okay, we have couple of topics are left, so we are almost approaching the end of the chapter. So the next topic is called vernier calipers, vernier caliper. Okay, in this chapter we are going to learn about two instruments which we are used in our physics lab, which is called, one is called vernier caliper, another one is called screw gauge. Today we are going to see the features and what is the use of this instrument. Okay, vernier caliper is an instrument which is used to measure in a very simple way. It is something called length, which is used to measure length. Then you have a questions to me, right? Of course, sir, to measure the length, normally we have scales are available, right? One's like a 10 centimeter scale, 30 centimeter scales are available. Then why we need additionally vernier caliper? The answer is quite simple. Vernier caliper is an instrument which is used to give an accurate value of an item in which we are measuring. Comparable to the normal scale, this will give you a perfect value. That's what we call it as, it's called vernier caliper, the device. We will see how this device can give you a perfect value of the measuring device. Okay, so we'll go to this one, vernier caliper. Before that, we need to know the fundamentals of a normal scale. Okay, let's see. For example, this is our, I have taken one scale. You can just mean it is a scale which is from 1 centimeter to 10 centimeter length scale. Okay, 1 to 10 centimeter length. So this is a position 0 to 10. So here I am marking the first position 1, and here I am marking second position 2, and etc. up to 10. You can assume like this. So within 1 we have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 divisions will be there. Okay, so let me make it like this in an easy way. This is called 0. We have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 and 10. So this is called 1. Okay, so between 0 and 1 we have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8 to 0.9. These many divisions are there. These many divisions are there. So I can say each division, this length will be equal to, total is 1 centimeter. And this 1 centimeter here divided into how many small parts? 10 parts. 10 parts are there. Okay, 10 parts are there. So for one part means this small distance. So this one part will be 10 part equal to 1 centimeter. So one small part is equal to how much? 0.1 centimeter. Okay, and this is the smallest value, or with the help of this scale I can measure with an accuracy of 0.1. For example, I am measuring a road like this. I have a road like this. I want to measure the length. I can say the length is, for example, 1.2 centimeter. I can say like this. I can say maybe 2.3 centimeter. I can say 2.6 centimeter. But I cannot say 2.67 centimeter. All these three values are possible, but the last value is not possible with this instrument. Why? Because this instrument is giving 1 point accuracy, which means 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. After 0.6, this instrument will give an accuracy of 0.6 to 0.7. Okay, so this will give an accuracy of 0.7. This instrument will never give you an accuracy of 0.67. So 0.67 measurement with this device is very difficult. It's not possible, because the division is division in the scale from 0.1, 0.2 up to 0.9. After 0.6, 0.7 will come. That is not possible to measure 0.67. Okay, this is not possible with respect to normal scale. This is the one of the major disadvantages if we are using our normal scale for measuring the length of a device. In this case, our brilliant guy will be here. This is called vernier caliper. Vernier calipers can be used to measure 1.2, 2.3, 2.6, 2.67. Which means this is a 2.6 and 2.67. Suppose if you assume like the value is 2.67 is the correct value of this rod, but this scale will either measure 2.6 or it will say either it is 2.7 centimeter, but it is not possible to say its length is 2.67 with the help of normal scale. To have this value, we need our brilliant guy, which is called vernier caliper. So vernier caliper is an instrument which is used to measure the accurate, pakka, specific value of a device which we are measuring. Here we are measuring a device of rod. Similarly, if you are measuring anything, whether it's a cylinder, whether it is a pipe, anything, if you are measuring, this vernier caliper will give you an accurate value. Okay, so this is a problem. So first we have discussed actually the problem of a normal scale. Problem of a normal scale. What is the main problem of a normal scale we have discussed? So this is a problem of a normal scale, but now we have something called vernier caliper which will avoid the problem of this normal scale. How this can be done, how this is possible, this is what we are going to see in this topic mainly. Okay, I will draw a rough diagram of vernier caliper. Okay, I'll do a rough diagram of vernier caliper. Before going to the diagram of vernier caliper, I would like to introduce one term is called least count. These are the some of the terms we must know in order to answer it. Least count, this is called LC. Okay, least count in case of an scale, as I told before, 0 to 1 centimeter area if you are taking 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 and 1. So this is 0.1, this is 0.2 and similarly up to this is 0.9. So 0.1 to 2 space will be there. What is the value of this one? 0.1 centimeter. So this is the minimum value I can measure with the help of this scale, and this minimum value is called least count. So least count is defined as it is the minimum value in which we can measure with the device. So with respect to the scale is a device. So with respect to scale, I can measure 0.1 centimeter accuracy. So this is the word meaning of least count. Okay, now we'll go to what is the architecture or how the vernier calipers are different. I'll do a rough diagrams. Okay, I'll to know the concept actually. So we have a vernier caliper is consist of something called a main scale. Okay, and here we have something called some jaws are there, and this jaw is connected with another scale, something like this. Okay, so there are two specific things. This is a very simple way. There are different types of vernier calipers are there. So I'm not going in depth into different types because it's not there in the syllabus. In your syllabus, you want to know what is the purpose and how it can be used. Listen very carefully to the board. So this is called J1 and this is called J2. This is called jaws. These two are called jaws. Jaws means like some teeth. Okay, like two teeth. And here we have something called some scale will be here. Maybe I will mark this scale something like this in a rough way. And this bigger scale is called a main scale. This bigger scale is called a main scale. And we have this small box. This small box will consist also have a scale, and this small scale is called a vernier scale. Vernier scale. Actually, this is vernier scale is an instrument is found out by a scientist, Pioneer Vernier. Pioneer, P-I-E-N-I-E-R. Pioneer Vernier is a scientist who find, I think the year is 1691, I guess. He found this device. That's what the name itself will becomes with vernier. Okay, because his second name is vernier. With the help of this device name comes with vernier caliper. Now how this instrument is used? how the instrument is used in the sense we have to see something called least count for a vernier scale. So for a least count we have calculated for a scale, right? For each division is each least count. This is one least count, one least count, one least count, one least count, one least count. So these all small gaps are called a least count. Similarly here we have to find out the least count. In case of a vernier caliper, there are two scales are there. One scale is called main scale, another one is called vernier scale, and we have two jaws will be there. I will tell you these two jaws, why these two jaws are used. These two jaws are used where we will, suppose if I want to measure the size of this pen, then I will keep these jaws will adjust, and in between the jaws I will place this pen. Then I will get the accurate value of the length of this pen. So these jaws are actually holding the item in which I want to measure the length, whether it is a cylinder, whether it is a sphere, whether it is a pen, a pencil, any wooden block or rod, any items I can fit it here so that I will get the exact length of this one. Now how the device is working is quite important. Before that, we also want to get the least count of the vernier scale. Least count of the normal scale we have find out. This is the least count of our normal scale. Now we are going to find out the least count of our vernier scale. So what will happen to our vernier scale? We want to find out the least count for our vernier scale. So this area, listen very carefully, this piece of area I am taking into here and I am zooming it out. Okay, zooming it, and this area alone I am drawing will be here. Based on that we are going to see few of the things. Okay, so main scale part alone I am drawing here within a bigger picture. So this is my main scale part. Okay, the main scale part is normally starting from 0 and up to go to 10 centimeter or 15 centimeter, 20 centimeter, 30 centimeter. Different scale will have different size, but just an example we are considering this is for 10 centimeter. Up to this one, for the 10 centimeter length I am just taking 1 centimeter length will be here. So this is actually the 0 position and this is actually the 1 centimeter positions. So how many divisions are there? As like we have told, we have 0.1 will be here, we have 0.2 will be here, we have 0.3 will be here. So similarly this will go up to, and finally we have what value we have, it will be here, we have 0.9 will be there. Then after 1 centimeter will start. So this is a diagram in which I have marked, this is called the main scale. This is the main scale MS. Now we have a sliding item is there. This sliding item is called vernier scale. What we are going to do in this vernier, this small piece of scale is placed here. The small piece of scale is placed here. I'll represent with another color. Okay, suppose I represent the small with a blue color. Understand the concept, that is important more than how beautifully you are drawing the diagram. Okay, here you can see 0.1, 0.1, 0.2, 0.3. How many lines are there between 0 and 1 centimeter? 1 to 9. Okay, so I can say main scale division will be equal to 9. There are 9 main scale divisions are there. Okay, and we are going to place, we already placed something called this blue color one. This blue color one is called vernier scale. Vernier scale will also have a reading like this, but the point of vernier scale means the vernier scale reading will be this blue color line I am marking. I can draw it to top. Okay, similarly here, similarly here, similarly here, similarly here, up to this will go like this. Okay, so totally if you're counting like this one, this is like 1, 2, 3, 4, and if you count like this one, if you fit will be here, you have 10 vernier scale divisions are there. So MSD equal to 10 and MSD equal to 9 and VSD will be equal to 10. Okay, so each of the 0 will coincide with the 0, which means 0 of, listen very carefully, 0 of vernier scale coincide with the 0 of main scale. but 0.1, 0.2, 0.3 of main scale is not coincide with the 1, 2, 3, 4, 5, 6, 7 other numbers of vernier scale. Blue colors are vernier scale readings and the red colors are the main scale readings. Both will not coincide except at the 0 point. So starting point, when the jaws are very close to, I mean these jaws are now open state. Okay, I can place some items to measure. He will be here. This is an item I am going to measure. If these two jaws are closed together, then the 0 will coincide with the 0. If I am moving, you can measure this blue color is my vernier scale and this is the main scale. Main scale is fixed. You can freely move this vernier scale. The small one is vernier scale which is sliding over. If this is your main scale, then this vernier scale can slide over on top of main scale. So we can slide it over here. So I can say based on this one, I can say MSD will be MSD main scale divisions equal to 9 and vernier scale divisions will be equal to 10. This is just an example for a 10 centimeter scale. Out of this one, 1 centimeter I have filtered it out. Okay, so what is called least count? A least measurable value. If you see this diagram, between every red to blue, blue to red, red to blue, blue to red, I can measure these small size I can measure, right? This small size I can measure, the small gaps between the gap between vernier scale line and the main scale line, this gap here, it is called least count. Here we have only one line in the normal scale, so this gap is called, we call it as what called least count for a main scale. But here we have two scales are there. Two scales are overlapped each other, so there is a mismatches are happening in between these points, and each gap is called least count. So I can say least count. Okay, least count equal to the difference between if we have taken this area, then I can say 1 main scale division minus 1 vernier scale division. Okay, if you have taken this area, so here this is main scale division and this blue color is called vernier scale division, and this gap, whatever I am shading this color, and this gap is called the least count. So least count will be equal to 1 main scale divisions minus 9, 1 main scale division minus 1 vernier scale division. This is called least count in case of a vernier caliper. Okay, this is quite important. So now we are going to do some calculations part, some formula sessions we are entering as usual in physics. So least count equal to 1 MSD minus 1 VSD. From this example, suppose I am assuming if I have any different vernier caliber will be there. So I can say based on this example, I can say 9 main scale division equal to 10 vernier scale division. Always remember, vernier scale divisions are higher number than main scale division. Main scale divisions are lesser. So in generally, I can say M main scale division, equal to some number, M may be any number. In this case, it is 9. So N vernier scale division. Okay, how we can remember this one? M, normally I remember like this. M is called Mahendra Singh Dhoni and V is called Virendra Singh Dhoni. Mahendra Singh Dhoni, it's bigger guy. Virendra Singh guy is chota guy. Okay, so bigger guy is M. M means bigger. Mahendra bigger. Then Virendra chota. So M MSD equal to N VSD. Mahendra Singh Dhoni equal to M times of Mahendra Singh Dhoni is equal to N times of Virendra Singh Dhoni. Okay, in this case we are going to find out least count. Least count equal to 1 MSD minus 1 VSD. Correct, that is called least count. What is VSD from this equations? What I can say from this one, VSD equal to, how I can say, M by N into MSD, I am substituting here. So 1 MSD. So I am just putting as MSD. 1 MSD means 1 into MSD. So which means nothing but MSD. 1 MSD minus 1 VSD means VSD itself. 1 into VSD. That's the meaning. So 1 VSD means what? M by N into MSD. So Mahendra Singh Dhoni will come out. Mahendra Singh Dhoni now out after a century. 1 minus M by N. 1 minus M by N. This is called what? This is called the least count. This is called least count. So least count will be equal to, as per this formula, least count will be equal to MST into 1 minus M by N. M is the main scale divisions and N is the Vernier scale division. So these two are brothers and sister, which means both are look wise it is different but comes from the same family. This equation is equal to these equations. First we got this equation, from this one we derived these equations. Hope you understood what is called a least count. So least count equal to MSD into 1 minus M by N into M by N. That's all. Okay, so this formula is very important. There are entrance questions are coming how to calculate the least count. Okay, yes, we have to move to the next topic. The main purpose, okay, I learned least count. Least count means what? This is a minimum size or minimum length I can measure, right? Least count, but it is not fulfilling our need. What is our need? Our need will be states that how we can measure the length of some device. That is our aim. So we'll see that. So let's see the question. I have drawn the diagram and the questions for you. Listen very carefully. Suppose I want to measure the length of a wooden block, and the wooden block I placed between the two jaws. Okay, so this, as I told before in the diagram, J1 and J2 are the two jaws, and I have placed the wooden block will be here. So I want to measure the length of this wooden block with an accuracy. That is the use of how to measure using vernier caliper. Means we are going to measure the length of the wooden block using VC. VC means, in short, I have written for vernier caliper. So to measure this one, we'll say initially this blue color line, you have to see, will be here. You have to listen very carefully because all are small lines. So here this first blue color line is the 0 point of the vernier scale. Okay, so the vernier scale, let me draw the vernier scales with a blue color line so it's easy for you to understand. So this blue color line is our vernier scale, and the red color lines, whatever we have drawn, will be here is our main scale. So we have vernier scale will be here, and we have main scales are there. Okay, next what will happen means when these two jaws are initially stick together. So what will happen in that one, the 0 point of vernier scale coincide with the 0 point of main scale. Now I placed a wooden block. So wooden block means in that case J1 is fixed and J2 is it's moved towards right. So J2 is I have a screw will be here. If I make the screw to be loose and loose and loose, I will get enough space will be here so that the wooden block will be handled. Now how to measure the length? Now you see from this area, as I told, each of here I am assuming this is a 10 centimeter vernier scale. It may be 20, it may be 30, 40, 50, 60, any number, doesn't matter. But here after drawing this one from J1 to J2, I fixed the wooden block and I have moved this J2, then tight it. So at this point, the vernier scale will be reached this much area, not the vernier scale, main scale. The vernier scale is moved. If I am moving J2 is connected with the blue box. So when J2 will be moving, this blue blocks will also move. So when it is connected like this, what will happen means this is moved this much area. So already this is the length. This length is I have marked as 0.8. Okay, suppose here 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. Suppose maybe we have 0.1, 0.2, 0.3, 0.4. So I'm just measured it. I have just counted these lines. Suppose I have 8 lines. I marked this total length equal to each line is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. So 0.8. When I'm taking 0.8 means just before reaching the 0 of vernier scale. 0 of vernier scale is starting here. Up to that, from main scale 0, how many divisions are there? 8 divisions are there. Each division is 0.1. So total length is 0.8. So now I am saying the length of wooden block. Length of the wooden block is equal to, this reading is called a main scale reading, MSR. Main scale reading plus I have to do the rest of the part. I have to do vernier scale reading. Now MSR reading I know. Okay, this much up to the 0, how much this J2 is moved. So up to this length is called main scale reading. So main scale reading in this case is 0.8 plus vernier scale reading we have to find out. To find out, here you can see 5 tick mark I have given. Okay, each tick mark is called what? Each tick mark is representing the gap between the red color and the blue color. The red color and the blue color gap is called least count. So you can see here it is red, then it is blue, then again red, then again blue. Then you can see at one point, definitely at one point, the red and blue lines will comes just one in line, one just behind that, both lines will coincide. So up to that line from here to here, how many least counts are there? How many least counts will be there? 5 least count will be there. So vernier scale division is equal to 5 into least count I measured. So 5 least count will be there. What is the value of a least count? One least count is equal to MSD into 1 minus M by N. So we have to find the least count first. That is a first step. Then if you want to measure the reading, what we'll do, we are taking MSR, main scale reading plus. So main scale is up to this, it is sliding down. So this area I can measure. Now here I will see where from the 0 I will look each line, first line, second line, third line, fourth line, fifth line. Yeah, fifth line, both the main scale line and vernier scale lines are coinciding. That is the point I will stop. That is the point I will look. From there I will see how many gaps will be. How many gaps means the gap between main scale and vernier scale. Each gap is called what? Least count. So here I given 1, 2, 3, 4, 5. 5 least count will be here. So vernier scale reading equal to 5 into least count. Least count, definitely we have to use this formula, MSD, Mahendra Singh Dhoni formula. 1 minus M by N, we will substitute and we will get 5 into least count. So once we calculated this 0.8, I have written just as an example. Okay, so just I have written as an example. So in a general formula, in a general way I can say reading equal to MSR, main scale reading plus vernier scale reading. So vernier scale reading, how I can write? N times of least count. N times, instead of N, let me put some other letter called K, because N is already written here. So K into least count. This is the formula to read the length of any item or any device. MSR plus K into least count. K is the least count number. Least count, we can use this formula. We can substitute here and we can find the value of this one. So normally the main aim is of this topic is actually to find out the value of an device which we need to measure the length. So that is the aim of this one. So here we have measured the length using MSR plus VSR. MSR means main scale reading, which means the main scale part, how much is a centimeter, we can easily see each division is 0.1, 0.2, 0.3, so like that. So totally main scale reading. And VSR, this 0.8 I have just taken as an example. VSR means vernier scale reading. Vernier scale reading will equal to number into least count. How many least count will be here, you have to calculate. You know how to calculate for a least count, we have to substitute. So in short, in the entire vernier caliber, topic, we have two formula. One, least count will be equal to, we have to find the least count and how we can measure the reading of a instrument. Okay, ready. Definitely I hope so you will do this experiment on your first year lab. Definitely at some point of time, once you get some chances, definitely this is a practical session in your first year physics. You'll go to lab, you will get some, either some cylinder or some sphere or some wooden block, anything. You have to find out what is the length of that device. You have to measure using vernier caliper. So in short, vernier caliper is a device which is used to measure the length or depth or diameter or anything related to a distance or length you can measure, but the accuracy of this instrument, it is very a precise value you will get comparable to our normal scale, because least count is a very small value normally you are getting. That's what, if you are multiplying these two, you will get some number of decimal places, which means this is giving a more accurate value. You will always get it. Okay, so that is important. You will always get it a more perfect and a more good value comparable to that of a main scale. Main scale in the sense our normal school your geometrical box scale. This is a very perfect devices which is called vernier scale. Okay, hope you understand this topic, and thanks for watching. And if you have any doubts, yeah, as usual, come back to me. Have a nice day. Bye bye.